Hi all, welcome to week 3 of BUSS1020. So week 3 of BUSS1020, we're getting into basic probabilities. Now, this week it's called basic probabilities, but it's starting to get hard, okay? Uh, Materials and concepts are starting to get difficult, and so this is where we have to really follow along and really be able to grasp every single idea, because in week 4, which is where I am recording it right now, it just builds upon each other. It just gets deeper and deeper and harder. So, without further ado, let's get right into Buzz 1020 for week 3. So we talked about an introduction to basic probability first. So probability, what is it? What is it used for? And some basic ideas and terminology around probability. And then we are going to be talking about basic probability concepts, calculations of these concepts, basic probabilities, conditional probabilities, Bell's theorem, and some counting rules, as well as ethical considerations, which is just some tag along ideas. Now, in addition to these, we are also going to go over the workshop. The tutorial Excel sheets for this week, which is really exciting. So let's just get right into it. So first of all, let's go to our notes for week 3. So so for week 3 notes, okay, that's a little weird. What is happening? All right. Anyways, for week 3 notes, we should be able to explain basic probability concepts as well as some terminology surrounding basic probability, conditional probability concepts, how to calculate them, what it means. Some probability rules as well, Bell's theorem, counting rules, and whatnot. Okay, so get right into it. First of all, what is probability? Probability is defined as the chance that that an uncertain event will occur. Okay, now this is often with the use of a random variable where the results of a test is random based on a pre-described chance of it occurring. So the chance is also referring to the probability of something of an event or event in question will occur or will not occur. Now, how many times an event occurs is a form of probability. Whether or not an event occurs is also a form of probability. That is what we call a binomial probability, where all possible events are mutually exclusive and collectively exhaustive, which means you could flip a coin, it is either a heads or a tails. So mutually exclusive means that if you get a head, you cannot simultaneously get a tail, whereas collectively exhaustive means that the probability of heads plus the probability of tails equals 1, which is 100%. So the idea of probability is defined as the chance of an uncertain event occurring. So probabilities are broken down into a priori, empirical, and subjective, and the three ways are the three ways to determining the probability. So empirical will be looking at past data. A priori will be using a knowledge. So here's the definition. Empirical will be based on observed data. Subjective would just be based on the expert's judgment of what the results should be. A priori is defined through obtaining probabilities through reasoning and logic. So, for example, there's a total of 6 sides on a die, which is singular for dice. But on your 6 side on the die, so each side should have 1/6 chance, and this is where we got some calculations for probability, where the chance of getting either numbers on a die should on a fair and unbiased die should be 1 out of 6, because the observation of one event 1 divided by the possible outcome 6. So these are the different types of probabilities that could occur. A priori, which means using logic and using reasoning to deduce the results. Empirical, using past data and past observations to make informed decisions about what the probability of an event should be. And subjective is where when the probabilities for an event occurring or not occurring is based on the judgment of experts. So, sample space is a set of all possible outcomes from an experiment. So, in an example of heads or tails, the sample space will be heads and tails. Whereas in the example of a die, the sample space will be 1, 2, 3, 4, 5, 6. So, all 6 sides of a die. So, sample space is a set of all possible outcomes of an experiment. So, they have to be collectively exhaustive, which means if you add all of the possible results together, we should all the possible results together, what we should get is the sample space. And each possible outcome of an event is called an event. So that makes a lot of sense. So getting a heads is an event, getting a tails is an event, getting 1 is an event on a die, a fair and unbiased die. Getting a 6 on a die is also an event. Now, events, there are 2 types of events. There are simple events, and there are also joint events. So simple events refers to events that just happen once. Events are described by 1 single characteristics. So either getting heads or getting tails on a coin flip. Okay. Or for this example, if a consumer buys a product, so it is binary, yes, the consumer buys a product, or no, the consumer does not buy a product. So there's only 1 variable and 1 characteristic that we should be concerned about when thinking about simple events. However, when it comes to joint events, it is described by 2 or more characteristics. So think of this as if I flip a coin and get a head, and then I roll a die and get an even number. So that would be a joint event because there are 2 or more characteristics and occurrences that have to happen in order for the joint event to be counted. So thinking of the example of the customer, if the customer buys a product and then pays more than $100, then that would be a joint event. Now, because there are 2 different characteristics right here. The first characteristic is if a consumer buys a product, and the second characteristic is whether or not the consumer pays more than $100. Okay, so that is the idea of a joint event. A complement of an event is subject to the outcomes that are not part of the event, noted as A prime. So A with that little dash at the side, that's called A prime. So this is the idea of it collectively exhaustive. So collectively exhaustive. So the probability of A prime is equal to 1, which is the universal set, or what we call the sample space minus the probability of A. So if we rearrange this, then we do A probability of A plus the probability of A prime should equal the sample space. Now that's just the idea of a complement. So A prime is the complement to A because A plus A prime, or probability of A plus the probability of A prime equals all possible outcomes. Okay, let's look at the Canvas modules really quickly. So introduction to basic probability. So yeah, how is probability used in business? So I didn't include this in my notes since I don't really think this is really that important. So once again, there are many uses of probability. Here are just a few: financial forecasting, product placement, product pricing is also another. We will see curves like this. If the pricing is right here, there's the most amount of customers. If the pricing is right here, there are less customers. Or actually, it shouldn't look like that. It should look something more like this. So if the pricing is here, there are too many customers. So this may be 0. So if the pricing is here and whatever, so as the pricing goes up, the amount of customers goes down and whatnot. So we have to use probability to determine that as well as graphing and distributions and whatnot. There are many uses in probability of business, and under introductory examples, the Monty Hall problem, which is not really that relevant. Readings of the textbook is here. So I think we touched on basic probability concepts. We touched on what the probability is, what an impossible event is, a certain event, an uncertain event, and simple and joint events, so only having 1 or having multiple characteristics, as well as visualizing events. Okay. So let's talk about marginal probability now. So let's open these. All right, so marginal probability refers to a simple probability, which only has 1 characteristic. Now, this is what we thought of just right here. So a simple event, whereas a marginal probability refers to a simple probability where we are only looking at 1 characteristic of an event occurring or not occurring, or how many times does it occur. Whereas joint probabilities considered multiple, so 2 or more events, such as probability A and B. So what is the probability of consumers buying a product and spending more than $100? So that would be a joint probability. Whereas a marginal probability would be what is the probability that a consumer buys a product, and that's it. Mutually exclusive events means that these two events cannot occur at the same time. So an example of mutually exclusive events would be the consumer spends more than $100, but this consumer also spends less than $50. Now you cannot simultaneously spend more than 100 or less than 50 at the same time. So that is mutually exclusive. Or another basic example is you cannot both get heads and tails at the same time on the same coin flip. That is just impossible. So those are mutually exclusive events. And the idea of collectively exhaustive events is that events, when added together, contain the entire sample space. So that is the idea of A plus probability of A plus the complement of probability A is equal to the collectively exhaustive sample. So collectively exhaustive population sample. So events that together cover an entire sample space is called collectively exhaustive events. Collectively exhaustive events do not have to occur at the same time. No, of course not. Which events are mutually exclusive and collectively exhaustive, then their probability sum must be 1. Now let's think about this in a case. So this is the entire sample space. This rectangle here is the entire sample space. In order for these two sides, okay, so there is the red side. So this is the red side. And then this is the blue side. Oops. This is the blue side. The red side and the blue side are mutually exclusive because they do not touch each other. And they're also collectively exhaustive because when we add these two together, we get the entire sample space. So this probability distribution right here will be mutually exclusive and collectively exhaustive. So that's the idea of mutually exclusive and collectively exhaustive. Let's look at this table right here. So we have event A occurring on the vertical axis, and then we have event B occurring on the horizontal axis. So the probability of event A1 happening with B1 is here. Event A2 and B1 is here. B2 and A1 is here. A2 and B2 is here. Now if we add these two together, we will get this. If we add these two together, we'll get this. If we add these two together, we'll get this. If we add these two together, we'll get this. If we add all the greens together, then we'll get 1. Now, the colors define whether or not these are joint or marginal probabilities or simple probabilities. Joint probabilities means that two events have to occur. So probability A1 and B1 occurring, so that there are two characteristics to this probability. Therefore, this is a joint probability. So all these blue cells, these are joint probabilities. Whereas these green cells right here, these are marginal, or these are sample probabilities. We said simple probabilities where there is only one event occurring. So this line right here, PA1, probability of A1 occurring is just this. It's just one event. So probability of A2, probability of B1, probability of B2. And once again, if we add these up together, we get the entire sample space of 1. Okay. So let's also talk about some general addition rules to probability. Before we get to that, let us look at the modules first. So marginal, we learned about that. Joint, we learned about that. Additional. Okay, let's talk about general addition rules now. So found by adding the marginal probabilities of event A and by subtracting the joint probabilities. So probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Now, I really have to visualize this. So first of all, let's just once again draw. This is the entire. That is one ugly sample space. Okay, let's draw this sample space again. So we have the red circle. This would be the probability of A. Okay, and then we're going to have the green sample. This is the probability of B. Okay, and now between the red and the green samples, we have a yellow area where there is both probability of A and probability of B occurring. So when we want to know the probability of A or B, we should add probability of A with probability of B. However, when we do that, we will count the middle yellow section twice. So in order to avoid counting the middle yellow section twice, we have to subtract. So that's why we subtract the probability of A and B. So that way, we will not count the middle value twice. Right. Hope that was clear. Hope the illustration helped a bit. Okay. So that is the idea of the general addition rule. So general addition rule is probability of event A or probability of event B is equal to the probability of A plus B minus the probability of A and B. Okay, so mutually exclusive, collectively exhaustive. Recap, these are the probability rules. And yes, okay. So conditional probability, let's talk about my notes first. So this is the general addition rule. We also have the empirical probability of a joint event A and B. So probability of A and B is equal to the number of outcomes satisfying A and B divided by the total number of elementary outcomes. So yeah, marginal probability of a set of joint events is equal to this. All right. So conditional probability is it's a little confusing, but we could get through it. So conditional probability is the probability of one event occurring given that another event has occurred. So the probability of one event occurring given that another event has occurred. Now, let me draw a Venn diagram really quickly. So this is the probability of event red happening. This is the probability of event green. Okay, it's way too small. This is the probability of event green happening. And then this is the probability of event red happening. And then in the middle, we have the joint probabilities of event yellow. Okay, so what is the probability of event yellow happening given that the green probability has already happened? So when we talk about given, we just disregard the red, okay? So what is the probability of yellow? So yellow, okay? So what is the probability of yellow happening given that green has occurred? So what we do is we take yellow and we divide it by green. So let's look at that. So we take the joint probability of A and B, so yellow and green, divided by the probability of green. So the probability of conditional probability of events A and B happening will be the intersection divided by the event that is given or has already occurred. Now, Bayes' theorem is used to revise previously calculated probabilities based on new information, and this is the Bayes' theorem. So a probability of B given A is equal to the probability of A given B multiplied by the probability of B divided by the probability of A. Okay, so conditional probabilities, so probability of A given B is equal to their intersection, okay, A and B's intersection divided by the probability of B, which the probability of B has occurred. Okay, so if we look at this if we look at this function right here, what this says is the probability of A occurring given that B has already occurred. So we look at their intersection, okay? We look at their intersection and divide it by the probability of B occurring. Now, another thing to take note of is if probability of A and B are mutually exclusive, then this doesn't make sense because 0, this would be 0 and then B would be a number, so that wouldn't make sense. So that would be, it would be 0 if if A and B are mutually exclusive. Okay, multiplication rule, so just know that and keep that in mind, be able to calculate operations with probabilities. All right, so yeah. All right, so Bayes' theorem. So Bayes' theorem once again is used to revise previously calculated information, given additional information. So if we have probability of B given A, then we will be able to switch it back into probability of A given B multiplied B divided by A. So so yeah. All right, let's talk a little bit about counting rules. Now, counting rules does not mean talking about 1, 2, 3, 4, 5. It talks about some numerical rules, okay? So, factorials, okay? So, let's talk about this. Counting rules are rules for counting the number of processes of possible discrete numbers of an experiment. Okay, so there are a few of these counting rules. The number of outcomes is equal to k to the power of n. So, for the example, rolling a die 3 times has 216 possible outcomes, since 6 to the power of 3 is equal to 216. So k to the power of n is the number of outcomes of a possible test. So what we do right here is 6. 6 is the number of possible outcomes of each of these trials, and 3 is how many times we want to calculate, how many times we want to roll this dice to know what the outcomes are. So there are 216 independent outcomes regardless of what sequence it is in. So we could have 2, 2, 3. We could have 2, 2, 2, 3, 2, 3, 2, 3, 2, 2, and these will all be counted as 3 different outcomes. Okay. So allows for numbers of events to differ when a die, for example. Okay, so these are different counting rules. All right, so the number of ways n items can be arranged in a unique order. So if, for example, we have 5 books, okay, we have 5 books. How many different ways can we rearrange this 5 books? We can have book 1, 2, 3, 4, 5. We can have 1, we can have 5, 4, 2, 1, 3. We could have 3, 4, 2, 1, 5. There are many different ways and different combinations of ways that we could arrange these different 5 books. Now, what the factorial tells us is how many different ways we could arrange these books in a unique order. So if we have 5 books and we want to order them in unique orders, then we do 5. Then we do 5 factorial. So 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And that gives us 120 different unique possibilities to arrange these 5 books into a unique order. A permutation is a number of ways of arranging x items selected from n objects in order. Okay, so that's the formula for permutation. All right, so I think we've talked about the counting rules, and the counting rules are just good to know. In the future, we will be using Excel for the calculations of probabilities, whether it be binomial, Poisson, or whatnot. But just know that these rules exist, and be able to understand the formulas, be able to explain what the formulas mean, and whatnot. So yeah, that'll be really helpful going forward. Ethical considerations. So yeah. Review. So here are the things we should be able to understand and be able to explain by now. All right. So let's talk about our tutorial. Let's talk about our tutorial. All right. So from this tutorial, we once again reviewed the 5-number summary. So if we look at this, we use the formula to calculate the 5-number summary for bank 1 and bank 2. So the mean, the Q1, Q2, Q3, Q4 for bank 1 and bank 2, and we want to be able to import these box and whiskers diagram. Once again, do you guys remember how to? So it is, you highlight them, you go insert, you go histogram, and then histogram, and a box and whiskers, and there we go. That is a box and whiskers diagram for Bank 1's 5-number summary. I think we learned about this last week, but okay. And then we are also able to calculate a lot of information about these. Now, once again, you could individually insert these box and whiskers diagram. However, you could also insert multiple box and whiskers diagram at the same time by highlighting both banks. So this question right here, question 1, was just a brief review of using Excel to calculate the 5-number summary, to calculate information about the number. So so I think we do this. We go analyze data, data analysis, analyzing. Why is it taking so long? All right. Anyways, so we can analyze data. We will be able to graph data into the 5-number summary, and that's really helpful. The second thing we did was building pivot tables. So in order to build a pivot table, we highlight the information. That is a bad way to highlight. So what we want to do is we do Control Shift, okay, Control Shift right, Control Shift down, so that highlights all the information. Insert pivot table, new window. Okay, so now we have a new window for a pivot table of this information. So once again, what this information talks about is we did a survey of whether or not people recycle their plastics. So they could either say yes or no. And then the next question is we ask the participants whether or not they participate in climate strikes. So whether or not they have ever participated in a climate strike. So our hypothesis is that there should be a correlation that people who usually recycle their plastics, usually people that have attended climate strikes usually recycle their plastics more than people who never attended a climate strike who recycle their plastics. So that's what we did. So what we did is we created this pivot table. To create a pivot table, we drag one data set to the rows, one data set to the columns, another data set to the values, and what that does is it inserts a pivot table. So right here we have whether or not they regularly recycle their plastics. So out of all the people surveyed, which is 857, let's turn out of 857 people surveyed, 657 regularly recycles their plastic, while 195 does not regularly recycle their plastics. Out of the 552 people who have answered the survey, 749 have not participated in a climate strike, whereas 16 people prefer not to say, and 87 people says they have participated in a climate strike. So let us instead of using these numbers, let us turn values into a percentage of grand total. That would make a lot more sense. So yeah, so that is the example of inserting a pivot table. So let us delete this slide. Right, so this is the example of us talking about the pivot tables, and we reorganize the data into yes, no, prefer not to say, yes, no, which makes more sense intuitively. All right, so I think that's a pretty I think that's a pretty good summary of week 2 of BUSS1020. We are really getting into the main materials, talking about probabilities this week. We're going to be talking more about discrete probability distributions in week 4. So we are looking forward to that. And yeah, I hope you guys have a good week. Hope you guys took something out of the video, and I hope to see you guys next time. Without further ado, take care and goodbye.